So, hi everybody, thanks for coming. I think it was pretty hard day for everybody and you are a little bit bored. So, I'll try to make you a little bit relaxing at the end of this conference. So, today I'm going to talk about Stencil, the tool that will give new home for web components. And before we start, I want to introduce myself. My name is Vitalii Bobrov. I am JavaScript developer at Luxoft. I'm working here in Poland, in Wrocław. And project I'm working on is financial application, not the only application, but some platform of applications. But for end user, it should feel like one app. So we are working for internal banking products that will give ability for bank employee to create some visualizations, data graphs, and so on. If you will have any questions about our topic, you can reach me out on Twitter or visit my personal blog on GitHub. So what we will be speaking about today. So first of all, I will tell some real-life story that will motivate you and will give you ability to have some reasons why we should use web components and Stencil. Then it will be some introduction to web component specification, what is it, how it's going. Then we will know what is Stencil exactly is. And we will deeply in Stencil API, and then I will give some tips how to get started and to write your own components using Stencil. So, the real life story. A long time ago, in a galaxy far, far away, a big bank of empire decided to build their own enterprise Death Star. It will be a big platform to destroy stars around the galaxy, and inside it uses technologies. Technologies inside was microservices built on Big J, our old Ute for enterprise applications, and on client side, web application built on top of Framework A. While time going, they built a bunch of components and instruments based on current front-end framework, and for end user, whole application feels like a solid one. They create branded components, buttons, grids, whatever. So time go, and sometime after that, some architects come to developers and tell that they should migrate to new framework A2. So it was a little bit crying for them because it means that they need to completely rewrite their application from scratch. No clear migration path coming. So this is the usual picture when business come to developer team with a new request. We have BA to translate business ideas into some technical documentation and project manager to give tasks for developers. And developer's job probably to implement what business needs. But over the time, another smart guys from another teams come and ask that could we use framework R for our part, or even framework V? Everybody was wondered, should we rewrite all our components from scratch again? It feels like you're gonna to kill somebody. But unfortunately, we need to look for another way to solve that problem. Because just all we want is reusable components. Components is the smaller building blocks of our applications nowadays should have smart and flexible API, and we should have ability to combine them to create some bigger components or even whole application. They should be distributed across the teams and adapted by them for their needs. Also, we want framework agnostic components, components that don't rely on any framework, but just web platform. And developers start to investigate what technology could it be? Is there any technology that could fit those requirements? And the answer, it is. We have web component specification come few years ago. So what web components is a bunch of specifications that allows you to declare your custom components, let's say custom elements, and it consists of 4 main APIs inside. So it's custom elements, ability to make new elements inside dictionary of HTML parser. It's something like CSS custom properties trying to do with CSS exactly. So next part is HTML templates. It's a part of your markup that is present on the page but not rendered until somebody will call for it. Shadow DOM is the way to encapsulate our markup or styles inside our components so it won't be affected by CSS cascade with styles or nobody can modify the markup inside. And JavaScript modules. JavaScript modules is used to reuse these components, share them. So somebody who want to use your newly created component just need to implement some JS module, and here we go. He can use it. If you look back to the history, components exist in web platform much more earlier than web component specification is, because we can explore the shadow DOM of browsers, and I think the first web components was form elements, because if you explore, for example, some range element, inside it has its own markup, it has its own properties for styling, but it's specific to each vendor. And it's exposed some API, and it's completely reusable. The only thing why we really need to re-implement such elements when we want some custom form controls is styling usually, because client wants some fancy drop-downs instead browser selects, and they want them to be similar on all browsers, no matter on which platform it's a go, and so on. So what about browser support for web components? JavaScript modules. I can say that nowadays it's pretty optional requirement, because we are still using such things like Webpack to compile, to bundle our JavaScripts and so on. So it's pretty optional one, but the support pretty nice for modern browsers, and unfortunately I, as usual, missed the specification. Firefox is in process of implementing this feature. Next thing, custom elements. And again, pretty nice support in Chrome, Safari, Firefox in development, each considering to develop this feature. And I, as usual, said man. Templates, pretty nice support, the only I missed again. Shadow DOM, it's supported in Chrome, Safari, Firefox in development, and unfortunately each and I missed. But do we really need support of all the features inside browsers? Web platform is pretty flexible thing, and it could be exposed and polyfilled. We need polyfills and fallbacks, because this is a picture how developers usually waiting for new feature support in modern browsers. We can wait for approval of specification and implementation of browsers, and we need it to be implemented in all browsers to be targeting. That means browsers that used by our users. And the thing that browsers want to implement features that are not used nowadays. And it's some like a circle dependency. So developers don't use the feature, browser waiting to implement it. So in the case, we should use polyfills for unsupported features before they are available. Why we should focus on web components? They are natively supported, standardized JavaScript components that could be used everywhere. They run in every framework on their own without any additional bindings, with some restrictions for React. But there is some good resource should we use web components, and you can check which framework has full support of web components. And for example, for React, there is some open issues on GitHub to simplify the usage, because in React you need to use some references to call the methods of web components and so on. It is the answer to our requirements to use shared web components problem. They powered by specifications that is good, because frameworks may gone, may created new frameworks, but the specification will be with us for a long time. And it's natively supported in most of modern browsers like Chrome, Safari, and for features that are not supported, we use polyfills. So could we create components using just custom element specification? The answer is yeah, but it may hurt sometimes. Let's look on some custom element example. Let's create some lightsaber HTML tag with some properties like size, color, and active to just mark that is activated or not. So how it could look in JavaScript? So it's just simple JavaScript class. We create a class, name it like lightsaber, and it should extend HTML element. For more specific use cases, we could specify another elements to extend, for example, HTML button element. What's the reason to do so? Is that, for example, button element has natively implemented methods like focus, all accessibility cases, so it's friendly for screen readers and have everything that you won't implement yourself every time. Here we have some static getter for observed attributes. We need this, it's a part of the specification, and we need this callback to define what properties we should observe during their changes. And then we use a callback called attribute challenge callback that accepts the attribute name, old value, and new value. Then we need some kind of switch case to handle reaction on each attribute change. And at the end, we need to imperatively define our custom element. We should call it, give him a name, and assign some class as a handler for it. The only restriction for naming custom elements that you should use at minimum 2 words with dashes. And the reason for such naming rules is to make safe the names for future HTML specifications that will come. Usually, developers use some prefix related to their own name or name of the company, and then the name of the component itself. But it's some basic things that we just declare and we are looking for properties. But usually we need more. For example, we might need to encapsulate our markup, style sheets, and so on. In pure web component, inside constructor, first of all, you call for super, and then you attach shadow DOM inside. Then you creating some markup and appending it to this shadow DOM. Also, you can attach event listeners to newly create nodes and so on. So pretty common DOM API stuff that you can do everyday job. Next thing that's gonna be useful is dispatching some custom events. Here is the example method that receives some properties. Then we have a specification for custom element. We should pass the custom event name inside, and then configuration object. Configuration object is pretty simple key value object that defines the behavior of our custom event. Should it be bubbled and so on. And the main thing here is that we have details. And inside details we can put any additional data we want to expose to DOM or another element. Then we need to manually dispatch this custom event after we create it. This in custom elements always referring to newly created element itself, the instance of current element. Also, we have additional callbacks for example, connected callback. It is used for some initial setup of your component. For example, API calls or adding some listeners. Disconnected callback is used to clearing it up the components after it will be destroyed. And attributes change we already mentioned before. So how it usually looks to build web components with specification? It may hurt, things might broke, and so on. Could we somehow ease this process? Do we have some handy tools that will help us? And the answer is yeah. There are some frameworks for that, and the newly created Stencil, that is not a framework. Stencil is just a reminder that it's not a framework, nothing to include inside your runtime and so on. But what is it? Stencil is a compiler. It generates native web components. It just puts your component-specific code and outputs simple HTML element. In this process, it just generates components. We can say that Stencil is a father of web components. But it's truth. So what's inside? It is a compiler that generates custom elements, the part of web component specification. It's not a framework, outputs 100% standards custom elements. Add powerful framework features to web components. We will back to this later. And it was created and used heavily by Ionic Framework team. If you have no idea what is Ionic Framework, it's a framework for building hybrid applications, mobile, for Android and iOS, Windows Phone. Now they're targeting also desktop applications and PWAs. So this is startup is existing from 2012 year. They created their initial version of framework based on Angular 1, then they migrate to Angular 2, but it was very heavy framework, and they decide to try out web components. And now in the latest version of their framework, they have already written they using web component generated by Stencil. It's not just simple compiler, but compiler with superpowers. Stencil combines the best concepts from all modern frameworks into a simple build time tool. Build time is really important because you have no dependencies on runtime, nothing to include except your created components. So what batteries is inside? First of all is virtual DOM that widely used in React, Vue.js, and it used to perform changes on nodes 3 in memory and then expose only difference as it changes to the actual DOM. JS6, or we could say in case of Stencil TS6. It's JavaScript for our templating, so we can use our commonly used array methods, for example, map, reduce, filter, if-else statements, no custom tags to define conditional rendering or repeating nodes, and so on. Also, it's widely used by React, Vue, and so on. TypeScript. We want our components to be type-safe because types at the same time become some documentation from your components. When you strictly type in your components API, inputs, outputs, it's easier to use it, and you have some handy tooling in your IDE or code editor that will tell you that something going wrong when you're trying to pass string where the number is expected, or you got this nice after completion, you got interfaces, and so on. And the good thing about TypeScript itself that it's just JavaScript. It uses every specification thing that reached the stage 3, and everything except the type system itself is a part of JavaScript specification. And even if you want to have any types, you can just omit you or use a big hack, type any. And but really, when you're working in team, it's not the thing you're going to do, because they will help you. Yeah, you need to investigate the overheads that you need to learn how to use it, how to define interfaces, how to extend them, how to use it partially, and so on. But then you reach more benefits, especially for big applications. And sometimes it could be integrated with some backend strictly typed languages. In our case, we have Java on backend, and it generates Swagger. And Swagger generates JSON schema. From this JSON schema, we create TypeScript interfaces for our REST API. So when somebody on backend changes some type of some property, interfaces are regenerated, and on next building of client-side application, you got the error that something going wrong. The interfaces are not matching anymore. You need to fix them, change something, or something like this. Next good thing is async rendering. It was inspired by React Fiber. It's the same idea, but more simplified. Because what is async rendering itself? It's the main problem in JavaScript animations or creating, deleting a lot of nodes, that it is done synchronously. And JavaScript as a single-threaded language and browser could become too busy to handle our work for us. And that is why we should use asynchronous jobs to perform changes on DOM or animating things. And async rendering is just things that doing that. They using such APIs like request animation callback, like request idle callback, to make things asynchronously and not to hurt our main thread. But in React Fiber, they go deeper and they chunking the jobs. So they perform some changes asynchronously. They calculated how much time it could take, and if it is longer than it could be to perform smoothly, it chunked, and the next bunch of changes will be performed on the next frame, on next render. Next thing, lazy loading. Stencil defines your custom elements only when you are actually using them. So if on current view you haven't used some authentication form, for example, so this component won't be defined on this view, and it will be lazy loaded on a login page. And as well, and all modern frameworks using reactive data binding. But why you should take time to investigate in Stencil? Performance. It performs well. It uses the all modern concepts that come in front-end area nowadays. And the reason why Ionic Framework team switched to web components was performance as progressive web applications. Even React has the size of 23 kilobytes for nothing. It's not your business logic, it's just the code of the library itself. And it's the size that you get in for nothing. React, not the biggest problem in such area, because, for example, Angular, they have much huger bundles, even for Hello World app. And size really matters on mobile devices, because not really the size in megabytes matters, but the size of code, because device need to parse it, inside the browser compiler need to optimize it many times, and it will use more CPU, and it may hurt the mobile device battery as well. So everybody want to reduce the code size, reduce the battery usage on progressive web applications. It's stable. Why? Because, for example, today we have React, Angular, but for some years they decide to close the project for some internal reason, no matter. Yeah, it's open source, but we won't support it anymore. And developers should think for another technology, need some proof of concept, and so on. And web components, as a part of specification, will be there for a long time. Of course, the specifications also evolving over the time, but it has usually backward compatibility, a lot of time to change your implementation while browsers. Nowadays, we have two versions of custom elements in browsers, like V0 and V1. And both of them are supported now. The deprecated one, APIs will be gone through the time, but you will know the date, and that's it. Interoperability, what does it mean? It means that we can take our component and we don't care what framework will use it, or no framework, or whatever. Or even it will be on the server side, render it and hit rate it and so on. So you just bind properties, use methods. It's just like an HTML element you're using for ages. And familiarity, because Stencil combines some features from frameworks. every developer that uses React, Angular, Vue, whatever, they partially already know parts of Stencil itself. Let's look for the same component lightsaber, but implemented with Stencil. So what is going on here? We just importing component, property, event, and so on, decorators. Decorators is a part of JavaScript standards. It's just like mixing functions. You wrap in your function constructor inside other constructor, modifying it, add some new behavior, methods, properties, whatever, and returning this class again. And that's it. It's just like a sugar for mixing out functionality. Even more, you can call it like a function to pass in parameters inside, and that's it. It will work exactly like a function. So the first and the main decorator for components is component decorator itself. You can define the tag name, style sheets, maybe enable shadow DOM, who knows. Then you define some properties. Properties might have some typings, even some simple one like number, string, boolean, or some complex one. For example, arrays or some interface for objects that could have multi values and so on, or even enum. And also, it's hard to handle some objects passing as a property to web component without using any technology, because you need to parse strings and so on. Every attribute on HTML element is a string itself. So even if user trying to pass array inside the property, it will be exposed back to the class as a string, and you need to parse it and so on. Pretty boring stuff. Then you can expose some custom events from your newly created element, listen for some events inside for your children, clicks, key downs, and so on. And the main method, render, like in React, you should return what is your component markup. It is JSX, so you can return if, else statements, and so on. So that's it. It's much more smaller than native one. If we want to implement something similar, the code base will be bigger, and it won't have all features like JSX and so on. It will take much more longer time to implement and to use. So what is the Stencil API? So mainly it's decorators. Like we mentioned, component to set tag name and enable shadow DOM. Then it's property. What is the difference property from just property on your class without any decorated? That on property change, render method will be called and your component will be updated. So it will look, but all your changes shouldn't mutate this property. For example, if you're using some array, it should always assign a new array inside modifying existing one. State is a pretty similar decorator, but instead of property, it don't allow you to pass down some properties outside of components. It's some internal state of the component. Event, just simple custom event trigger. Listen allows you to listen to children events inside your JSX. And element, the reference to DOM node itself. So it's pretty looks like something else. And really it is. For example, if you look on decorators, we have the same or analog decorators in Angular to now at 5. So component is the Angular component, properties like Angular inputs, event like Angular outputs, listen like host listener or declarative listening in templates. element and element reef. But when we're talking about lifecycle hooks, it's more similar to React one. And they are pretty much each other. Component will load is the same like component will mount in React. Component did load the same like did mount. Checking for updates have the same name. Component did update have the same name. And the difference in component did unload and component will unmount. You might be confused with all this stuff, but it gives you ability to understand Stencil even if you don't know the Stencil but know React or and also the good thing that it's some kind of gathering of communities because we're using ideas from both of ecosystems in one place. So how Stencil is different from another frameworks, libraries, tools, and web components. Stencil differs from Angular, React, and Vue that it builds standard web components that have no restriction to any framework. The only case I know that somehow it could be transferred components between React and Vue, but not from Angular. And usually some re-implementation of some element in another framework means to writing it from scratch, because framework may have its own paradigm and use cases. The another thing that pretty similar to Stencil, but it is a framework for web components, is Polymer. It's also created by Google. And instead of Polymer, Stencil haven't its own template syntax, own binding, own helpers for everything, and it uses some not opinionated things like JSX, Virtual DOM, and so on. To integrate such things in Polymer, it is possible, but it requires a lot of work from your side. And vanilla web components, Stencil gives you ability to simplify complicated things, boilerplate, and so on. So Stencil is not just another tool. It's a pretty big combine of tools that allows you to create not only the components, but whole libraries of components, expose them, register them on demand, server-side render them, and so on. How you could start with Stencil? Unfortunately, now Stencil don't have any CLI or create Stencil apps thing. It's just a simple Stencil starter GitHub repository with bunch of instructions, and inside it you have some predefined Webpack build or imported libraries and so on. It's pretty boilerplate. It only includes app component and some hello world dummy component. Then you need to clone this repository, go inside the directory you already cloned, and run npm install and npm start if you're using npm, or yarn and yarn start. Next thing that you should do is check official documentation of Stencil. And the interesting thing that stenciljs.com website with documentation is built on Stencil itself. It uses Stencil router, a bunch of core components that come from Ionic team, and so on. Documentation is open source. Website for documentation also has its own repo on GitHub. You could contribute to documentation, to fix issues, typos, and so on. And the last but not least thing to check is articles from the community. The first one, how we create a smile to unlock with Stencil.js, is pretty awesome because it's not only about technology but some fun. Asim, the author of this article, created a custom element that unlock your login when you're smiling. So it uses Azure machine learning to recognize what on the picture and define if person between monitor is smiler or not. If not, they won't log in, and so on. So that's all from my side. Thank you, keep calm, and use the platform. If you have any questions, you may reach me out on Twitter and write me a direct message or tweet. The slides will be shared after this presentation in a few minutes on all social networks, so you can pick up, try it, and so on. In case you have any questions, I think we have some time. You may ask them, if some. Yeah? Yeah, yeah, yeah. The same as you're doing it in React, you're using this connect function usually for Redux. It's just a function. And Decorator, for example, is just a function, but some sugar around it. So you can write your decorator like connect, pass the properties you want, and return new class with bindings from your store. In this case, I think you're gonna to create some library of dummy components. Like in React, you create some folder for components that takes only dummy one. And the same, you create in library, and then you just import these dummy components and then wrap them in some connection, decorator, function, whatever. Or even you can achieve it with a way like Polymer doing it. That defines some declarative elements to work with Redux. So they have element like Redux store and so on. It's a pretty interesting idea, but haven't chance to look inside what is going on. But as Polymer teams always says, we have elements for everything. They have elements for fetching something or another things. They deeply using and widely this declarative approach for everything. We are in process of using it in our process. We started to implement some pretty simple stuff like drop-downs, accordions, and so on. And fortunately, we have only two technologies, React and Angular 5. Angular 5 working like a charm, just add some use custom element schema, and here you go. You just bind properties and so on. In React, it's a little bit tricky, but they have already these issues for because they have another way to bind it, attributes and properties. And that is the case. You need to put this reference and use some methods through this reference inside your methods inside React component.
So suppose I have an large application
Mm.
in Angular, let's say modern Angular 5.1, and today I'm deciding, okay, we start developing with Stencil. I'll compile my all Angular components to web components. I'll use Stencil and I'll compile it to the Stencil.
So you can do it step by step, like, so you have your application and you choose some small element, for example, button to re-implement in Stencil. So you create new library in Stencil, define this button and replace your component written in Angular 5 with your newly created stencil one. Overhead.
If I compile Angular component to some web components and leave it.
They have this like an experiment in Angular now. It called Angular Elements, and they try to. They have such experiments for this thing, but they support web components out of the box. It's just element. The only thing is that compiler cares about properties on elements, and if Angular don't know properties, they will throw the error for you. That is why you should put such property on your module that use custom element schema that will pass all these warnings.